Hello everybody, welcome here to another video by JFB, and in this video we're going to take a closer look at one of the components of the von Neumann architecture. If you didn't watch the previous video, I stated in the previous video that the von Neumann architecture mainly consists of one, the CPU itself, and within the CPU we find parts like the LLU, the CU, and finally the registers. That's what we find in the CPU. In all CPUs, whether you're using your phone CPU, your laptop CPU, and anything like that, there's always an LLU for mathematical calculation, the CU to coordinate how the CPU functions, and the registers to store the individual instructions and data. Two, we had input and output. This is simply the things which you use to get data into the computer, that's input, and we finally had output, the things which are used to get data outside the computer and show you the user. So we had the CPU, input, output, and finally we had the memory unit. So the memory unit is simply a place where your instructions are stored, and the instructions, I don't mean an individual instruction like add, I mean all the instructions of how the program is going to work. That's where your data which is being used by the CPU is stored, and all those things, they're all stored in the memory unit. And the memory unit mainly consists of RAM. That's what it is. So this is where the RAM comes in to play a big role inside your computer. So the RAM is used to store the entire program whilst the computer is executing the instructions within the program. And don't get confused, buses, like a normal bus which you climb and go to some destination or location, they're used to transport things, or you can say they carry data. So they transport or carry data to and from the CPU between the RAM. So that's what you can think of. So they transport data mainly between the CPU and the memory unit, and in this case the memory unit consists of RAM. That's how you can think of buses. So these are just things which will transport data from the RAM, take it to the CPU, and they'll transport more data from the CPU, take it back to the RAM. So like they're the transporter between the CPU and RAM. All your instructions and data which are going to the CPU are being transported on buses. So now let me show you how a bus looks like. I've wondered and thought of it like most people learn by actually seeing what I'm talking about, not by me just writing on the whiteboard. So let me show you RAM, CPU, and the buses, all those things into one thing, using a simulator which I recently opened up. And that simulator is this simulator. As you can see, this is your RAM, and these are buses. So buses are actually wires, but it's not like a single wire which is transporting anything. You'll find like 8 wires, and when that wire is carrying a voltage, it's actually carrying a 1. So whenever you have wires like this, and this will be a single bus, and that bus will be maybe called the address bus, which I'm just showing you. And every time you are carrying a 1 from the CPU to the RAM, there will be a voltage here, so it will be a 1, and maybe there is no voltage here, it will be a 0 and 1, maybe if there's a voltage, another 1 if there is a voltage. So that's how data is transported from the RAM to the CPU. That's what all the buses do. Don't even wonder about how is that even possible. Just know that the CPU will get data from the RAM via buses. That's all the things. And buses carry data as voltages or currents, you can name it anything. I don't know so much about physics, but every time like there's a current flowing through the wire, it's a 1. Current is not flowing through the wire, it's a 0, just like that. So let's go back to the simulator and we continue seeing the PC in action. So the whole thing which you're seeing in pink here with the pink background is the CPU. Then with the blue background is the RAM. So these buses are carrying data from the RAM and taking it to the CPU. That's how it works. Now let me clear out the whiteboard and explain more about the RAM, then we'll talk about the buses. So RAM stands for random access memory, and from these words you can actually get a sense of what RAM is. So random means the CPU can get any location in RAM, and don't worry, I'll talk about location next. Random means the CPU can get any location within RAM at random, Access just means it can access that data and it's memory, so it's storing data. That's what it is. So RAM is extremely fast. That's the key factor about RAM. It's extremely fast. And if you're wondering, well, when you're copying a program from a flash drive and all those things, you don't actually copy the data from or the program from the flash and take it directly to RAM. You actually copy the data to maybe an SSD or an HDD. This is where all your programs live in. This is why this is like a permanent storage. That's something you have to think about. This is permanent. That means when you turn off your computer, everything will remain and it won't go anywhere else. But when you turn on, you'll find the data again. Now for RAM, it's temporal. So this temporal, you normally hear it as say that it's versatile. That's what you hear most instructors say. RAM is versatile. That means it stores data temporarily when the computer is on. That's what it does. So RAM is fast, it's versatile, and else it also allows for random access. That's what you must master about RAM. It's random access. And by the way, RAM can be directly accessed by the CPU itself. So the CPU can directly access all the contents in RAM and use those contents to execute some instructions. That's what it is. If we go back to the simulator here, you can actually see that the RAM and the CPU are sort of communicating to each other via the buses. That's what you can see. So the CPU can directly access the contents of RAM via buses. But as you can see in the simulator itself, there's no like hard drive which is storing all those things. The hard drive comes to play a critical role in storing things permanently. So if you have like Microsoft Word, and you want to run Microsoft Word, you launch Microsoft Word and Microsoft Word will then be put onto RAM. Then on that RAM, that's where the CPU will now be able to process Microsoft Word's instructions, all your typing and all those things. So you can kind of think of it, you have a hard drive here, then you have RAM here, and you have the CPU here. So every time the CPU wants to carry out some instructions or maybe execute a program or run a program on all those things, the program will be stored on the hard drive permanently. Then if the CPU wants to run that program, it will be loaded onto RAM. And when it's on RAM, the CPU can actually execute those instructions within the program. I also want to highlight one of the most important aspects of RAM. RAM is partitioned. So what do I mean that RAM is partitioned? So you have a stick of RAM like this, then you have partitions within that RAM. That's what I mean. And in each partition, so this is a partition, by the way, this is a partition. In each partition, you find an address and the data. That's what it is. So in each partition, you find the address and the data both in the binary format. So they will both be just ones and zeros. Those ones and zeros will be stored here. So this might be address location 1. And by address location 1, the RAM won't signify it by just writing a 1 here. It will write actually a binary number. So it writes 00000001. And then maybe you find data like just a number like this and all those things maybe. Then the next address location will be 2. So it will be 00000010. And this is 2 in binary format. If you don't know why this is 2 in binary format, I have an entire series, go watch it. So then you have more data here. I don't know, it will just be 0111110, something like that, and so on and so on. So for the next address location to be 0000011. This is address location 3, and so on. It will continue on like that. So these partitions and all those things, this is an address. Just remember, this is an address. So like where the data is actually located. So if the computer wants whatever is stored at address location 2, and the RAM will give what is stored at address location 2 to the CPU. That's what it is. So you have the address and finally you have the data. So address and data. Now let's go back to the simulator and actually see how these things work. So the CPU can make a request and say, I want whatever is at location 00, and that will be 100 and that, and the RAM will give the CPU, all that data. So as you can see, it was incrementing from 000 to 001, 0010, and all those things will continue incrementing. So this is just a 1, 2, 3, 4, 5, 6, 10, and all those things in just binary format. Now, how is data going to travel to the CPU? That's where buses come and play a key role. So buses are just wires. That's all you're supposed to know. Buses are just wires that transmit data. That's all you're supposed to know. So if you hear anybody say, no, this bus and all those buses, a bus is just wires which transport data between the CPU and the RAM. So that's how data travels from the CPU to the RAM, or from the RAM to the CPU. Now, there are different kinds of buses. So the first kind of bus is an address bus. So the address bus, as you might tell from its name, is responsible for carrying addresses. So the addresses which I was talking about, which are found on the RAM, this is the bus which will carry those things. So let me go back to the simulator and actually show you the addresses I'm talking about. So this bus you can see here, and it's a one-way bus. So it only carries data from the CPU to the RAM. It only acts in one way. The RAM cannot use the address bus to transport data to the CPU. And this address bus only carries an address. So when the CPU makes a request on, I want something at address location 1, this a 001 will be loaded on the address bus, and the RAM will give this value of 0111 back to the CPU via the data bus. And going back, that's our second bus called the data bus. So address bus carries the address, but the data bus will actually now come and carry the data. And this data can be either going from the CPU to the RAM, or it can be going from the RAM to the CPU. So it's a two-way thing, as you can see even in the simulator. So data can either travel from the RAM to the CPU, or from the CPU to the RAM. So maybe if the computer calculates a number of 7, the 7 will be transported from the CPU to the RAM via the data bus, and it will be stored somewhere here. So the computer will say, I want to store this at memory address location 5. So it will load the 5 on the address bus, and that 5 will go to the RAM, and the data will also be carried there. So it will go on address 5, then write whatever is on the data bus to that value. That's all it does. The next and final bus is now the control bus. So the control bus, as you may think of it, is simply the bus which carries instructions. It's sort of a control to the RAM. What do I mean is sort of a control to the RAM? So this bus can either carry a signal of maybe read. What do I mean by read? Or maybe to carry a signal of write. And what I mean by this is simply that the control bus can carry, say, I want to read something at memory address location blah blah blah, and the RAM will actually do it. Let me go back to the simulator and actually show you what this is doing. Going back to another example, if the CPU was to say, I want something that's at address location 3 here, it will send an instruction on the control bus here, and I'll say, I want to read. Then the RAM will interpret that instruction and get the address at the address bus and give the data at the address bus via the data bus, and all those things go to the CPU. So here it can carry instructions. If I want to read, it will signal that to the RAM via the control bus. If it wants to write, it will signal that to the RAM via the control bus. In short, that's how the CPU controls the RAM in order to do what it wants. So if it wants to read, to load, and all those things, it will be carried via the control bus to control the RAM and maybe even another component like that. So those are just buses, and as you can see, buses essentially just carry data. But in case of the control bus will carry instructions. That's what it will do. So with that, it's a wrap to this video. Thanks for watching. Please leave a like, share, and subscribe. Thank you.